All right, so this is the next one of our videos, and this is now a continuation to our actual calculus version of this. So we have some curve here, and what we're going to do is find the center of mass of this curve, and we're assuming that the thing is evenly distributed mass-wise, that it has an equal density throughout the entire thing. So how we're going to do that is we're going to make these formulas, which are the actual formulas for the x and the y coordinate, based on this rectangle, just like we've done before. So you can see I've taken the midpoint, because if you have a rectangle, the center of mass of that rectangle would be dead center. It'd be at the midpoint of the x's and the midpoint for the y's. So right there. So I've already got it labeled. That would be x sub I, because that's the midpoint for our point. And if you were to plug that x sub I into f of x, you would get f of x sub I. So half of it would be where our midpoint is, right there. And so if we take this rectangle and we find how to find the midpoint for that one rectangle, we can then apply it throughout the entire curve all the way across by adding them up and thinking about this delta x again going to 0. So it's super, super small. And so if we use that, then we know that it's m1 x1. That's what we're going to start for our moment, right? And then once we add up all those moments, we would then divide it by the mass, which is the total mass of this entire thing, which is just basically the area times rho. All right, so our mass here is rho times area. That would be the mass of this rectangle, because we need to take the density and multiply it by the area to find the mass. So we have rho area. So the area here has a width of delta x and a height of f of x sub I. So I've already plugged that in. You see rho, and my area is f of x sub I delta x. So that's all that is. We take f of x sub I, multiply by delta x, it gives us the area of this. Multiply it by rho, it gives us our density. Our mass. And then all I have to do now is multiply it by x sub I, because that's our point. So over here, each of our points m1, y1, right, is just going to be based on this same situation, but for y. So we're going to get rho times the area, and that's not going to change. The rectangle is the rectangle. So it's going to be delta x times f of x sub I. That is our area right there. But now our y coordinate is this one. So you can see all I'm doing is going f of x sub I times delta x times rho times our location, which is x. And then over here, the same exact thing times our location, which is 1/2 x sub I. So that's the moment for y. That's the moment for x. So now if we use our formula that we have here and here, and we treat them like a sum, so each of our points, m1, m2, m3, m4, all of our moments, right? So our m sub y is what they like to call it. But I really want to use m sub x, but it's just a moment to rotate about the y. So this would become the sum of I equals 1 to n, right, of rho. And then we're going to put the x sub I first. So x sub I, f of x sub I, delta x. And then if we now apply our limit as n approaches infinity to give them all of them, so now our delta x is going to approach 0. It's going to get really, really, really thin. We can now make our integral. So it's from a to b, and then it's going to be rho x f of x dx. So you can see that's where our formula comes from, right here. But that's just our moment. So how do you turn it into it? Well, we know that x bar is going to be that my, right, divided by the mass. Well, what is our mass here? Our mass is going to be the area of the entire thing, right, times rho. That was our mass, right? That was the mass of just this one rectangle, so it'd be the mass of the entire thing. So this is going to be my all over, and then it's going to be rho a. Well, if you notice, there's already a rho sitting here, the density and the density. So what's going to happen is we're going to end up with the integral of a to b rho x f of x dx all over rho a, and they cancel. And so what does a represent here? A represents the integral of this entire thing. So it's the integral of our function. So this becomes the integral of ab x f of x dx over the integral from a to b of f of x dx. Now do not cancel those, because that is not what we're saying here. You can't split the integral. But that's where we use 1 over a to make it a little bit easier. So your a here is the integral from a to b of f of x dx. It's just the area under the curve that we've been doing from the very beginning, right? Okay, so we can take and apply that same situation here over here. So you can see we have f of x and f of x. So what this is going to become is rho with a 1/2, and then it's f of x squared dx. And so if we apply the exact same thing, the sum with the limit and the integral, the rows are still going to cancel, and so we're going to end up with this. So we're going to end up with y. Let's do our moment first. We're going to end up with the moment of x is equal to the integral from a to b of 1/2 rho f of x squared dx. And then so to find our y bar, it's going to be mx over our mass. All of the masses added up, right? So this would become, again, mx. Let's change our mx already. Integral from a to b of 1/2 rho f of x squared dx of rho a. And you can see again, it cancels, giving us the integral from a to b of 1/2 f of x squared dx all over a. And so this gives us our formula there, just like before. And our a, again, is the integral from a to b f of x dx. So these are the formulas we're going to be using. That's going to give us the x coordinate for our centroid, and that's going to give us the y. Now, I do want to show you it in Desmos. And so we found one x. And so like I was saying, we're going to go all the way from a to b, giving us our center of mass. It's going to take all of those points, just like we did before. Remember the 3 points we had? We're now going to take all these infinite points and do our multiplication that we've been doing, our m1y1, m1y1, and then divide the entire thing by the mass. So that's all it's doing. It's just like those 3 points that we did before, where we took all the x's and added them up, times their x times mass, x times mass, x times mass. And now we're doing it to infinity. We're getting an infinite number of points. So 0.1, 0.2, 0.3, 0.4, 0.5. That's all this is m1, x1, m1, y1. And so it's really going to be mi, yi, mi, yi, xi, and so on throughout the entire problem. And we end up with these. All right, so let's try one. So first we're going to do is sketch the region of this. And what we're going to do is use a calculator to do it, just to get our region, and then we're going to calculate everything else with the calculator as well. So I plugged in my y equals y rad x and my x equals 0, and I'm hitting zoom 0. And then we're going to go back and hit zoom 6, which is our standard. I got zoom 0 on my mind, which is fitting it. So we're going from 0 to 4. So you can see our region right there. That's the region we want. So that's what we're going to sketch. So we want this and this, and we're going from 0 to 4. And so that would be our rectangle that we're dealing with, and that's our center point. That would be our x sub I, and that would be our f of x sub I. Just like that. So basically, if you look at the height of our rectangle, that's what we're looking at for our f of x. Whatever's the height of this thing is our f of x. So the height of our rectangle here is the rad x. So that would be y equals square root of x. So our f of x for this problem is square root of x. And we're going to have an a equal to 0 and a b equal to 4. So now we can plug them in. But if you notice, they both have a. So the first thing we want to do is find out what our a is. And that's just the integral of our f of x from 0 to 4. So once you've written those 3 things, all we have to do now is say a equals 0 to 4 square root of x dx, and that's going to give us our area, which is 5.33. And we're using a calculator here. We just want the approximate. So 5.33333. So what that represents, right, is the area underneath the curve of that entire thing. And remember, the densities are canceling here. So it's not the mass, because we don't have a density yet, but it is the area. So if you knew the density, you could calculate the mass by multiplying this by that row. Now we got to find our x. So if we go back up here, you can see that x is just 1 over a, integral from a to b of x f of x. That's where we got it from. So again, it becomes the x-coordinate times the area, basically. That's all it is. So it's x times a height of f of x, delta x. X f of x, delta x. So our x bar is equal to integral from 0 to 4 of x radical x dx. That's all it is. It's the integral. Let's actually write that out, what it is. It's a delay on my eraser. So it's 1 over a, integral from a to b, x f of x dx. So I like to put the 1 over a at the end because you've already got it entered in the calculator. You can just grab it. So it's 0 to 4 x radical x dx. And now we can calculate that in our calculator. And so all you have to do is go up and grab it, scroll back over, hit second, insert, and throw the x in. That's it. And then now you can take this one, divide it by this one, and hit enter. And there we go. So we're just going to say 2.4 is our center. And now we do the same with y bar. So y bar is 1 over a, integral from a to b, and then this one is our f of x. So we have a 1/2 f of x squared dx. And again, that one happens that way because, again, it's the area times the y coordinate, right? That's all it is. So we get the delta x f of x times 1/2 f of x. So you end up with 1/2 f of x squared delta x. So 1/2 f of x squared dx. And then we plug that in. So it's 1 over a, integral from 0 to 4, 1/2, and then it's f of x. Oops, f of x is square root of x squared dx. And so that one is, we can just plug in x. And so we get 4, and then we go back and divide it by our area, which is the 5.333, and it gives us 0.75. So now we have our points. That is our center of mass, 2.4, 0.75. And that's it. So all I have to do is basically plug them in the formula. Let's do one more, but this time we're going to use an exact value, not a calculator. I do want to go back and look at that one again with Desmos, though, since I've already got a nice graph for it. You can click on that and play with it. So you can see our rectangle here and where the formula is coming from. And so for the x, remember, it's just the x times the area. And so it's delta x f of x. So it's just x f of x delta x. So it's x f of x dx. That's our integral for the x coordinate. And for the y, it's 1/2 f of x times f of x dx. So that's where we're getting 1/2 f of x squared dx. And then we just divide by the entire area, which is the integral beneath. And again, that's just one point. We have to add up all of the points, which is what our integral does, is it takes and adds up all of those points and masses together, right? So that would just be our mx and my right here to get that point. And then we take the integral and it adds them all up, every single one of those centers, to give us the center of the graph. So it's kind of a cool idea, is if you find the center of one rectangle, well, you take and find the center of all of them and add them up, and it gives us our centroid. All right, so let's try this one now. So we have y equals e to the x, y equals 0. And this one we can graph and do everything by hand. So we know y equals e to the x looks like that. It goes through 1. And then we're going to go from y equals 0. So again, that's our x-axis. From x equals 0 to x equals 1. So now that we have our graph, if we draw our rectangle in the middle, right there, you can see that our f of x is the y equals e to the x. So our f of x here is e to the x. Our a is 0, and our b is 1. So again, we got to find our area first. So from 0 to 1, e to x dx. So this would be e to the x, 1, 0. So it'd be e to the 1 minus 1, because you're going to plug in 0 and you get 1. So that's our area. So at the end, we're just going to divide everything by e to the 1 over 1. So again, we're finding that rectangle, and then we're going to take our integral now and go through the entire thing. So we just found the mass, right? Not really, because there's no row. So we can just think of our row as 1. We found the mass of this entire region here. And now what we have to do is find our moments. So again, it's going to be x1 times the mass of this rectangle, which is dx times f of x. So we're going to get x, f of x, dx. And then we're going to find the y coordinate, which again would be the y times the mass. So it's 1/2 f of x sub I times f of x dx. So that's where we're going to get 1/2 f of x sub I squared dx. So again, it's x, f of x dx, and 1/2 f of x sub I squared dx. So 1/2 f of x dx, 1/2 f of x squared dx, which gives us our formula. So now if we plug it in, remember we leave the 1 over a until the end. We're going to go from 0 to 1, x e to the x dx. And so we're going to have to use integration by parts. So we say u equals x, dv equals e to the x, because the u will get simpler. It becomes a 1. I don't know why I wrote 1. We can just write dx, just like we did with du. And our v becomes e to the x. So then we end up with 1 over a bracket, and then it's x e to the x minus the integral from 0 to 1 of e to the x dx. And then so this is 1 over a, and then it's x e to the x minus e to the x 1, 0. All right, so now all we have to do is plug in 1 into here and then the 0. So we plug in 1 over a. We're not going to plug that in. We're just going to write it. And then we get 1 e to the 1 minus e to the 1. That's our first one. Minus 0 e to the 0 minus e to the 0. Okay, so that 0 is going to make that one 0. We can cross that off. And that one would become 1. So we get e to the 1 minus e to the 1, which is 0. So we can cross those off as well. So all we're left with is minus minus 1. So that's 1. So we end up with 1 over a, which is 1 over e to the 1 minus 1, because that would become positive 1 times 1 over a. So now we know our x coordinate. Now all I have to do is find our y. So y bar is 1 over a, integral from a to b of 1/2 f of x squared dx. And if you forget these, you can write them down. All right, so now we just have to plug everything in. 1 over a, 0 to 1, 1/2, and then our f of x is e to the x squared dx. So this would become 1 over a, integral 0 to 1, 1/2. In fact, we can actually take that 2 out just to get out of the way and go 1 over 2a, integral from 0 to 1, e to the 2x dx. And so now we can take this one as a nice clean integral. It's 1 over 2a times, and then it's 1/2 e to the 2x. And then we check it just real quick, because you always make mistakes here sometimes. Well, not always, hence sometimes. So e to the 2x derivative would be e to the 2x times 2, and the 2 cancels with the half, taking us back to e to the 2x. So that's perfect. 1 to 0, and so we get 1 over 4a e to the 2x, 1 and 0. So now we plug that in. 1 over 4a e to the 2 times 1, which would be 2, minus e to the 0. So we end up with 1 over 4a e squared minus 1. And then here's where the tricky stuff comes in. So now when you plug it in, you get e minus 1 down here, right, for the a. We already had a 4 there. So what we're going to do is put 1, 4, e minus 1. That's what we get here. The area is e minus 1. I don't need the 1 anymore. 1 over e minus 1. And we don't need the 1 up here. We can just erase it. All right, looks good. Now, the reason I know it's tricky is because now you can take and put that one at the top, like that. We can get rid of that one. Now, if you see e squared minus 1, that's factorable. It's e minus 1, e plus 1. And the only reason I'm factoring it is because on the bottom I have an e minus 1. So when you get your answer, you'll notice that it doesn't have that e squared anymore. That's because they factored it, and you end up with that. So now we have the exact location. It's 1 over e minus 1, comma e plus 1 over 4. And that is the location of our centroid here, or our center of mass of this shape. So again, just to go over these, all you're doing on every single one is basically using an integral to plug in every single situation that happens here, where you're taking your x sub 1, all those centroids are those rectangles. You're taking your x sub 1 and you're multiplying it by the area, which is our mass. In this situation, you can just ignore the row because it's going to cancel with the area. And then you're taking that y location, which is 1/2 x f of x, and you're multiplying it by the area. And then you're adding them all up with an integral and then dividing it by the total area. That's all this is. And so that's why your 1 over a is kind of stuck out there. This is your moment, and that's your moment, and divide by a, divide by a. So try to understand these, because it'll help you when you form and find your f of x. But you want to just draw that rectangle, and whatever the height of that rectangle is, that's your f of x.